Hello, everybody, and welcome to my class. Today we will be talking about probability again. Okay, and here's our schedule. First, we're going to start with our usual warm up and review. Then we're going to be doing some warm up questions, and then we're going to be solving problems. Okay, so can everybody see my screen? Are there any questions? No questions. No questions. Okay. Then I'll start now. So for our review, we have of course we have what is a factorial because that is really important. So a factorial is basically the product of a specific integer and all the integers below it, including 1, right? So what is 5 factorial? Be 1 times 2 times 3 times 4 times 5 equals 120. Okay, what is 3 factorial? What is 3 factorial? Put that in the chat box. Okay, what is 3 factorial? You should know this already. Just a couple of formal questions. Just put it in the chat. Anyone? Okay, 6. Very good. It's 1 times 2 times 3 equals 6. Very good. And now we have our permutations and combinations. So what are permutations? Arrangements of linear sequence. Okay, so let's say we have A, B, and C. Okay, we arrange them. We can do B, A, C, C, A, B. Those are arrangements. And how do we solve? We use n factorial. Okay, is that clear? N factorial. And that will be n times n minus 1 times n minus 2 times, and it goes on until 1. And what is n? N right here is going to be 3, and N denotes the number of objects in our subject, in our set. Okay. So, how many permutations of A, B, C, and D? How many permutations are there of A, B, C, and D? Please put it in the chat. Okay. How many permutations of A, B, C, and D? Okay, please put your answer in the chat. This should be a very quick one. Okay, Kai, C 4 factorial, very good. And 4 factorial is going to be 24. Very fast. Good. That is going to be our answer, 4 factorial. Now combinations, okay? It's arrangement, it's, okay, the number of a specific selection of objects within a larger set, okay? And let's say we have A, B, C, D, okay? We're supposed to pick sets of 2. Sets of 2. We can pick BC, we can pick CD, whatever. Okay. We just have to pick sets of 2 from this set A, B, C, and D. Okay. So that will be, and we need to use our combination formula right here, n factorial over r factorial times n minus r factorial. Okay, so how many objects in the set? That would be n 4 factorial over 2 factorial times 4 minus 2 factorial equals 24 over 4 equals 6. 6 sets of 2, okay? And remember, the order matters, okay? Permutation's all about order because you're arranging, right? Okay, but combinations order does not matter. Let's say you have a set of 2, B and C. It's the same as BC is the same as CB, okay? Does not. So are there any questions so far? One comment and okay. So this will be our review. Now let's go to our introduction to probability. So our introduction to probability. Okay. So let's review what probability is. So the definition of probability is numerical descriptions of how likely an event is to occur. Okay. So how likely is how likely are you going to pick a red shirt from a set of 4 shirts in which 2 shirts are red? Then the probability would be 2 out of 4. Okay? And please remember this. Okay, probability will almost always be a fraction. Should be the desired outcomes over all outcomes. Okay, so in this case, we want to pick out red shirts from our set of 4 shirts, right? And we have 2 red shirts in this set of 4 shirts. Then we would have the desired outcomes would be 2. All outcomes would be 4 shirts. Okay, is that clear? Now, so let's say the 4 shirts is going to be let's say the shirts are all red. All red, then the probability would be 4 out of 4, because if they're all red, then you must pick a red shirt. So in this case, the probability would equal 1. Now, let's say our set of shirts, there's going to be 2 red, 1 yellow, and 1 green. Okay, what is the probability you pick a black shirt? That's not possible, right? Because there are no black shirts in our set. So that'd be 0 out of 4 equals 0. So the only times when a probability isn't a fraction less than 1 or greater than 0, okay, so probability is going to be less than, okay, greater than 0. Greater than or equal to 0. And then it's going to be less than and equal to 1. Okay, can't be greater than 1, can't be lower than 0. Okay, it has to be 0, 1, or any fraction in between those two numbers. So it's almost always going to be a fraction. Okay, the only time when you're not going to have fraction as probability is when you're going to have a 1 or a 0. Is that clear? Are there any questions? Who has any questions, or are you trying to take notes on this? No questions. Okay, good. So, now let's move on to our methods. Okay, so, our different like counting techniques, methods, or probability methods. Counting technique and probability, those methods are about the same. Exclusion, case by case, box method, they are the same. Okay, probability, the only difference really is that you're dividing by something. Okay, so you're counting the desired outcomes and then you're dividing by all the outcomes. Okay, so what is box method again? We use these little boxes, and for, let's say, we're finding a 3-digit number, then these boxes are going to be factors or aspects of the whole case. And then let's say we're finding 3-digit numbers, right? How many 3-digit numbers in all are there? Okay, and how many choices? Okay, excuse me. How many choices are there for the first digit? Okay, the 100th digit. We have 9 choices. 0 through 9, except that 0 can be used or that will not be a 3-digit number. So 9 choices. Next, we will have 10 and 10 equals 900. Very cliche. This example, you probably heard it many times. Okay? That is basically box method, and we are going to be using that a lot in this lesson. So box method, make sure you know that. Exclusion. Exclusion is basically taking all outcomes minus, okay, the unwanted outcomes. If you take all the outcomes and you subtract the unwanted outcomes, then you'll get the wanted outcomes, the desired outcomes, right? So that is one way. Okay. Now this you usually do when you have many cases, okay? And case by case you can it's basically just figuring out the desired outcomes. Okay, it's literally just figuring out all the desired outcomes. But that is all only possible when you have not a lot of outcomes. You have less cases. Because if you have 100 cases, you can't possibly go through them all and find out which ones are correct. Okay, so in that case, you would use exclusion. Is that clear? Are there any questions? Anyone? Okay, no questions. No questions. Okay, so now we will do our warm-up question. Okay, so Gerald has 3 red, 2 green, and 5 orange shirts. What is the probability that Gerald picks out a red shirt? Okay. Now for these warm-up questions, these are quite easy, so I expect everyone to get an answer that is correct or an answer that is pretty close. If you guys do not get a lot of them correct, then I'll have to write out another question like this. Make sure you know how to do it, as this is a very common one. The shirts one, very common. Okay, so make sure you know it. So, number 1. Okay, let me repeat. Gerald has 3 red, 2 green, and 5 orange shirts. What is the probability that Gerald picks out a red shirt? Okay, please put your answer in the chat. We have 3 comments. 1 comment already. 1.3 out of 10. Wait, no, I read that wrong. Number 1, question number 1, 3 out of 10. Very good. 3 out of 10. That is correct. Okay, and only Kaixi answered. Is anybody else going to answer? No. Okay. 3 out of 10, Jason also. Very good. Let's, to make sure you know this one, because only 2 people answered. Okay. Let's change up the numbers a bit. What is this? 2. Okay. Now try to do this one. Gerald has 2 red, 4 green, and 6 orange shirts. What is the probability that Gerald picks out a black shirt? What is the probability of picking out a black shirt out of all these other shirts? See? What is the probability? 3 comments. Tian Chen, very good. 0 out of 12, and Kaixi also says 0 out of 12. Exactly. 0. The answer is going to be 0. Very good. Very good. So, on to our next one. Bob has 5 marbles. 3 red, two blue, and two blue. Okay, what is the probability that he will pick out a red marble? I'll give you a few moments. This should be quite a fast answer. And I assure you, these are just warm-up questions. The other ones will be a lot harder. I'll give you more time to solve this. So, 3 out of 5. Okay, very good. He and Tianchen. Very good. And also Jason, you're doing well too. Okay. You have 3 and 2. Okay, you have 3 red and 2 blue. You have 5 marbles in all, right? And then you have 3 red of them. So where the desired outcomes get, you have 3, right? Over 5. Very good. Okay. So let me tweak this a little bit. What is the probability? Okay, Bob has 5 marbles. Okay, 3 red and 2 blue. I'm not gonna change that. Okay, what is the probability? Okay, Bob picks 2 marbles. Okay, this time we're picking 2 marbles. What is the probability? What is the probability that the second marble is going to be red? What is the probability that the second marble he picks is going to be red? Okay, and so Bob picks 2 marbles out of 5 marbles, 3 red and 2 blue. What is the probability that the second marble he picks will be a red marble? Now, let me give you a little hint. So, with the second marble being red, we can have red and then red, okay? But we can also have blue and then red. So there's 2 possibilities right here. Okay? So this is much harder. And this uses the addition rule, okay? Probability. And okay, this is much harder. So please put your answer in the chat if you do know. Actually, I think I had the same style of this question in last class because we were picking boys and girls. Okay, what is the from a group of 4 boys and 2 girls, 2 children are selected, right? And what is the probability that the second child selected is a boy or girl? I don't remember. And you're going to use the same method here, okay? Okay, see, 3 out of 10. Are you sure about that? 3 out of 10. Okay, 3 out of 10. That actually might be right. Are there any more answers? Carney, whether you've done pretty good this semester. So, Carney, do you have an answer? Okay, I'll go back. Sorry if I switched too fast. I'll give you a few more moments to think about this one. But this is pretty hard. So. Okay, Kaishi is the only one that's given me an answer. So, do you guys need more time to think, or do you not know? Okay, do you need more time to think? I'll give you a few more moments. I need to go to the restroom real quick, so I'll be back. And keep thinking when I'm gone. Okay, I am back. So no answers. Then I'll walk you through this one. Okay. So no answers. So so we have two possibilities, right? We can do red red or blue red. Okay. Red red plus blue red. The probability of red red, and then the probability plus the probability of blue red. That is the addition rule of probability. So we will continue now. So what is all the outcomes for, let's just solve for red red right now. And the blue red will be similar. Okay. So for the red red, what are all the outcomes? Let's solve for all the outcomes first. First we have 5 marbles, right? That will be, we have 5 choices for our first pick. Okay, our second pick will only have 4 marbles because we can't replace. We can't replace these marbles. Okay. So 5 times 4 now. And already I notice. Let me see Kaixi's answer again. Already I notice that Kaixi's answer is out of 20 or 10. You can simplify it. And that is, she's on the right track, I think. Because our denominator is also 20. Okay? So, now for the red red. For the red red, first we have 3 red marbles to pick from. Is that right? You have 3 red marbles to pick from. We have 2 marbles. 2 red marbles to pick from. We get 6 out of 20. Okay, that is part of Kaixi's answer. But we're supposed to add another probability. So Kaixi, your answer is going to be incorrect. But you did solve for the red red. But I think you miscalculated because you forgot to put the probability for the blue red section. Okay? And let's solve for the blue red now. The all outcomes is going to be the exact same. Now for the blue red, we have 2 blue marbles to choose from for our first pick. Next we have the 3 red marbles for our second one. And wait, this is like basically the same as red red, right? It will also be 6 out of 20. Okay, so we just add them now. So that would be 3 out of 5, right? Yeah, that would be 3 out of 5 because 6 over 20 plus 6 over 20 would be 12 over 20, and then we simplify, divide both by 4. Okay, get 3 over 5. So I see, do you understand why? Oh, you don't get it. Okay, I'll clarify. So, and I don't blame you if you don't get it. This is a pretty hard question. So I'll explain again. We need to focus on is the second marble pick. The second marble that we pick has to be red. Just the second marble. There are no restrictions on other marbles. Okay, the first marble we can have it be red or blue. Okay, so that's why we have two possibilities here. We can either pick a red marble first, and then we pick our second marble, which is also red. That is a possibility. Now, our second possibility is that we choose a blue marble first, and then for our second one, we choose a red marble. So for these two possibilities, okay, and that is key right here. So once we solve separately for these two probabilities, we just need to add them. So this is for the red, okay. This is for the blue, red, okay. So for the red, this is all the outcomes. We're supposed to pick two, right? And we're gonna pick one after the other, or we wouldn't have second marble or first marble, okay? We're gonna pick them one after another, and for the first one, we have 5 marbles in total, right? For our first choice, okay? And our second choice, we have 4 marbles. Second choice, we have 4 marbles. Then our whole outcomes would be 5 times 4 using the box method, okay? So as I said, box method is pretty important. And for our desired outcomes, we're supposed to pick red after red, right? So red. And using the box method, first we need to pick a red. We have 3 choices. Now we already picked a red. We only have 2 choices now because we can't replace these marbles. They're not replaceable. Okay. And for the blue-red now, we have the same all outcomes. We still have 5 marbles, okay? And then we're supposed to pick the blue marbles first, okay? We have 2 choices. We have 2 choices as blue. And then we multiply with 3 red marbles, we get 6 over 20. Okay? And now we just add them. Okay, we add them. So we add red, and blue, red, we get 12 over 20, which is going to simplify to 3 over 5. So that's everybody understand. Oh, okay. Very good. So, as I said, the second marble has to be red. Okay, the second marble has to be red. I did not say anything about all the marbles being red. But if you were really calculating for all the marbles being red, yes, you would be correct. This would be all marbles being red. Yeah. Okay. Very good. Hold on, let me do something real quick. Hold on a sec. Okay. Never mind. So now let's do practice problems. So number 1, Gerald rolls 2 6-sided die. What is the probability that he doesn't roll a prime number on either of them? So he doesn't roll a prime number on either of them. So before you solve, make sure you understand the question. We think we talked about the steps of solving a combination or counting techniques or probability problem. Okay, the steps first, you have to analyze the problem. Okay, so in the last problem, Taishi didn't understand the problem, and I think I didn't write it too clear. So that's my fault. Sorry for that one. But for this question, I wrote it out pretty clear. So make sure you analyze it first. Make sure you understand every part of it, and then answer. Okay. Yes, x over 12. X over 12. You have x over 12. So basically you already solved for our all outcomes. Okay. However, are you sure it's x over 12, Jason? So let me give you a little hint. Jason, what you solved for was 6 plus 6. Now we have 6 choices from both die, right? So using the product rule, we're supposed to multiply them instead of add them, okay? So, like Kaixi, okay, very good. 36, okay, 36. Yeah, it is x over 36. Very good. And Kaixi, 3 over 4. Very good already. Uh, oh, yes. 3 over 12. Yes. Uh, that would be 1/4. Okay. So now we will solve. But do you guys need more time or do you want me to just solve? Okay. Okay. Very good. Then I'll just solve that. So, Kaishi's answer is correct. Congratulations. And actually, I don't know yet. Looking at the problem, I just solved it mentally in like 15 seconds. But it should be correct. It should be correct. So, basically, we have two-sided die, right? So, going to have two die, right? We have two choices, okay? Multiply two different probabilities. Last time we added them, okay? But this time we're supposed to multiply them, okay? And we already found our all outcomes. So what is the probability that you don't roll a prime number? Let's look at all the numbers first. Six-sided die, okay? And if I remember correctly, yes, this is actually a math counts problem, okay? This was in the sprint round, okay? This is a math counts problem in probability, yeah, if I can't remember. Yeah, this was a math counts problem, okay? And I think I put a couple more math counts problems in there and I'll notify you when we get to them. So 1, 2, 3, 4, and 5, 6, okay? And out of all these numbers, okay, which of them are not prime numbers? Okay, he doesn't roll a prime number, okay? So he wants to pick those that are not prime numbers. But let's pick out the prime numbers first. So we have 2, we have 3, and we have 5. Now, 1 doesn't count, okay? Because 1 is not a prime number. 2 is the lowest prime number, okay? So 1, 4, and 6 are not prime numbers, okay? So we have 3 choices. The same on the other die. And what you see here is actually 1/2 times 1/2, which equals to 1/4. Okay? Is that clear? So does everybody understand? Oh, yes. Uh, yeah. Dice, okay? 0 rolls two-sided dice. Thank you for correcting my grammar mistake. Okay, so very good, Kaishi, and the others who got the correct answer. Very good. Okay, I don't know why, but Frank is draining on and off. Maybe he has problems with his Wi-Fi or something. Uh, but second problem. Okay. Randomly choosing two numbers from the set 1, 3, 5, 7, and 9 with replacement. Okay, you can do replacement. Okay, with the marbles we can't do replacement. Okay, but with this one we can replace the numbers. So what is the probability that the product is greater than 44? Okay, you choose two numbers from the set. With the probability that the product is greater than 44. Let's say you have 7 times 7 equals 49. Yes, that is greater than 44. Now you're going to find every case and then divide by all outcomes. And did I just say case? Yes, I did. And that is a hint. You're going to use case by case on this one because there's not a lot of cases and you can figure them all out in like a few seconds. So this one, case by case, is probably going to be the best answer or the best method to use for this one. Okay? So I'll give you a few moments. Actually, a lot more than a few moments because this one takes a while to find those cases if you're confused with this stuff. Hmm. Yes, Frank, internet issues. I thought so. And Jason, okay, 3/5. Okay. Kaisi, do you have an answer yet? Carney, no? I'll give you a few more moments uh think more about it and also check answer, make sure it's reasonable. Okay, make sure it's not greater than 1. Okay. Carney, I think last time you asked if the probability can be greater than 1. Okay, make sure your probability is not greater than 1 or a negative. Okay, because that is not possible. Okay, Kaisi, you have comment? Okay, yes. Yeah, of course. Why do I? Okay, I'll leave the question up this time. I'll give you a few moments. Okay, no answers yet. I'll give you a few more moments. went to swim practice at 7 in the freaking morning. Huh. Yeah, very nerve-wracking. And what kind of question is that? Are you single? Hmm. Of course. And Carney, 2 over something. Ah, 2 over something. I can tell you that it is probably much greater than 2 over something, unless it's 2 over 2, which is going to be 1, and that's not going to be very less. So, let me solve it for you. And as I said, case by case. Okay, case by case. So, let me see. Okay, let's see. So we have 5 times 9, okay? We have 5 times 9 equals 45. Yeah, also have 9 times 5 equals 45. So we already have 2 pairs, okay? That the product is greater than 44. That's already 2 cases, right? Very fast. You see. So please use case by case on this one. Also have 7 times 7 equals 49. Okay, 7 times 9. Okay. 9 times 7. 9 times 9. 81. What is it? So we have all these choices, and I think we have 6. Yes, we have 6. And now we have 5 numbers in this set. So in all outcomes, and this is with replacement, okay, our first number we have 5 choices. Second number we also have 5 choices because we replaced the number that we used on the previous one. So that's all going to be all outcomes. Now we just have to put these 6 cases in there. 6 over 25, which equals about, let me get my calculator out. Wait, no, I don't even need my calculator. That is going to be 0.24. Because just multiply 25 by 4, and then both numbers by 4. 6 times 4 is going to be 24 over 100, 0.24. Very easy, okay? Okay. So, next problem. Number 3, 2 number cubes, each with the digits 1 through 6 on the 6 faces are rolled. What is the probability that the product of the 2 numbers on the top faces will be greater than 6? Another dice problem. Yes, I know. And I'll give you a few moments to try to solve this one. Okay? And this one is part of the harder ones we are going to be doing. So please take your time with this one. Okay? I'll leave this slide up. No answers yet. 11/18. 11/18. Okay, 11/18. Jason, another 11/18. Actually, I don't know if it's correct yet, but let me see this question. Okay, two number cubes. 1, 2, 3. On the outcomes 36. Okay. Product of the two numbers. We have how many? We have 3, 4, 5, 6. Another 6. 5. So we add them together. We can calculate it out. Okay. Add them together. Okay. 22. 22/36 equals 11/18. Yes, that is correct. 11/18. Very good. Very good, Edward and Jason. So now I will solve it for you guys. Okay. Okay. So now so we also use case by case on this one. So we're supposed to we're supposed to find the products of these two numbers, right? And let's say the first picked number will be n. N. Okay, and the second one will be m. N times m is greater than 6. Okay, that is going to be our inequality here. Has to be greater than 6. Okay, now when can n equal 1? No, it cannot, because m, the greatest m can be, is going to be 6. And 1 times 6, that is not greater than 6. So n cannot be 1. It can only be 2 to 6. Okay. So when n equals 2, then m has to be greater than 3, because 2 times 3 is going to be 6. And how many numbers are greater than 3 and less than or equal to 6? It's going to be 4, 5, 6. There's 3 possibilities. And when n equals 3, m has to be greater than 2, right? And how many possibilities? We have 3, 4, 5, 6. 4 possibilities. N equals 4. Okay, what do we have now? We have 3/2. 3/2. Okay, so how many greater than 3/2? We have 2, 3, 4, 5, 6. Right? 2, 3, 4, 5, 6. We have 5. Okay. N equals 5 now. M is greater than 6/5. Yeah. Now we're getting to the fractions. Okay. There still should be 5 possibilities. It would be 2, 3, 4, 5, and 6. Those are all the possibilities that m can be. Now n equals 6. M has to be greater than 1. How many possibilities? Still 5. Add them all together. 15 plus 4, 19 plus 3 would be 22. And what are all the possibilities? Because we're supposed to Remember, with a lot of dice problems, we're going to be 6 times 6. Going to be all outcomes. 36. Okay. Now we simplify. 11 over 18. Okay. So as you see, you must figure out when you are going to be using case by case or exclusion or box method. Okay. Very good. So now our last problem. Fred picks a ball from a jar of balls. 5 red, 2 yellow, and 3 green. What is the probability? What is the probability that he picks a ball that is not red nor green? So not red nor green. Okay? So now solve. Number 4. I'll give you a few moments. This is quite easy. We'll end off with an easy one. Okay, Edward and Jason, Steve, you've all done pretty well. Okay, so I expect an answer from you. And Carney, you only give me a few answers today, so make sure you do this one. 1 over 5. Okay, very good, Jason. You're the first one, and Edward also 1 over 5. Okay, very good. And why? Because if you pick a ball that is not red nor green, then it has to be yellow, right? So it's basically going to be yellow, yellow balls over all outcomes. So it's going to be 2 over 10 equals 1/5. Very good. And with that, I'll end our class. Thank you for listening, everybody, and please like this video and subscribe to my channel. Thank you for listening.